Cool. Hello everyone. So my plan for this stream was just to test out like solving a few problems. Kind of a casual stream. Tomorrow we're gonna have a more exciting stream, um, where there's some post here. I have this blog post where I've outlined some number theory problems I think people might enjoy doing, and we can discuss them on the stream. But yeah, let me just check. All right. Let's see. Um, Trying to decide what problems to do on today's stream. I mean, this one seems like it might be good. Nah. All right, I'll try a geometry problem. Cool. So actually, all right, cool. So getting back to it, let's try solving this problem. It's a little smaller, and I'll set this to the link. And let's try out using this. Using this Jamboard. So we have this experienced internet user who has to compare the sizes of circles. The inner circles are the same. Okay, so what you have to do is, given the radius of the inner circle and the number of outer circles, you have to exactly determine the radius of the outer circles. Cool, okay, and this makes sense. Like in this example, you have a ton of outer circle, or I guess n is the first number. In this example, you have 100 outer circles, so each one is very small. And this is where you have 6 outer circles, so each one is exactly the same size as we kind of expect. Let me get my drawing set up. All right. So let's see. That's not the right size. Okay, so let's say this is our outer circle or our inner circle, and then we can draw some of our outer circles. So whenever you have circles, I think a good thing to do is to draw the centers. So this radius is R, and this radius is capital R. And let's see if we and we also know that this radius, I guess I'll zoom in a bit. This would also be R. All right, I'll full screen this. Um, cool. Let me know. Let me know also if you can see the diagrams clearly. I'm still experimenting with this drawing setup. Cool. So then I guess we can draw. Hmm. So if we draw the line that's tangent between these two circles, I'll draw it in a different color. This line, because this diagram is symmetric between these two adjacent circles, this line should also pass through the center here. What can we actually do with this though? Hmm. Let me. If anyone in the chat has any ideas, just shout them out. Yeah, definitely feel free to subscribe to my YouTube if you want to see these videos and possibly other videos later, though so far I've only uploaded stream broadcasts. Make this a little easier to see. Oh, um, so I actually drew this diagram kind of poorly. The key point here is actually that where these circles are tangent, if you draw their radii actually form one continuous straight line of length 2r. So I guess then what we have is, all right, I guess let's just try to just use trig to get this out. All right, so let's say this angle here is theta. Then we have sine theta equals r over r plus r. And that's because if we take this right triangle, that's like the definition of sine. So, and the, whoa, whoops, that's a highlighter. Cool, yeah, and then we know theta in this case. There are n of these circles, and theta is half the distance between two circles. So that would be 360 degrees, or 2 pi, divided by 2n. Um, yeah, so then we could actually, I guess, just rearrange this and solve it. So we'd get r sine theta equals r times 1 minus sine theta. What problem is that? 100C. Yeah, cool. Yeah, so if you type exclamation mark link in the chat, this bot will reply and tell you the current problem that I'm working on. And I kind of just picked this problem at random. Let me know if you have any suggestions or ideas for other problems or concepts that I should try to target. Definitely happy to do that. Let me refresh chat to make sure I can see everyone. Cool. Cool. And as a check on this answer, there's actually kind of a neat trick you can do to make sure that you didn't mess up any algebra or anything. This is kind of borrowed from physics. So if you imagine r is in some unit, like meters, then capital R is in this, it's going to end up being in the same unit. So for example, if you had something like r squared here, you would know that you definitely made an algebra mistake because that wouldn't make sense. Right? You wouldn't have meters on one side and meters squared on the other side. Yeah. Another way to think about it is just by using similarity. If you scaled the whole picture up by a factor of 2, you would expect both small r and big R to scale up by a factor of 2. which would only work if they had the same kind of power or degree on both sides. Cool. So let's try coding this up. Let me just pump up my font size. Whoops. Cool. And then solve C. Cool. So the input format is int n double r, read n and r, and then theta would be how do you actually get pi in C++? Arc cosine -1. Man, it's maybe I shouldn't make it an int. All right, let's try running this. Cool. All right. It looks like this is probably right up to the fact that they want to be within some like error. Cool. Um, yeah. Does anyone have any? I guess I'll type it in the chat. If you have any problems, suggestions, or requests. Otherwise, I'll probably just find another random geometry problem and do it. Okay. Let's see. So CSL99 says they have a problem recommendation. So let me click that. And Joshi503 says wait. All right. Why should I wait? What's up? Do you have a question? Definitely happy to try to answer. I didn't get the editorial. Cool. All right. Okay. I'm gonna stop waiting for Joshi503. But if you remember what you wanted to say, definitely let me know. Right. 1800 difficulty. Oh, this problem. Count. All right. That's a very fun meme problem that Joshi sent. I can cover it after distance entry, which I'll look at first. All right, so A tree is a connected graph that doesn't contain any. Oh, I'll first of all, I'll use the contest link instead of the problem set link. Let's just check that it's working. Cool. All right, so we have a tree. It's the number of edges between two vertices. Find the number of distinct pairs of vertices which have a distance of exactly k between them. Note that, okay. This problem looks familiar, but I mean, clearly I haven't done it because it's not green. The number of distinct pairs that have exactly k distance. Cool. All right. Let's try drawing something for this. So let's draw the first example. So, all right, so we have 1, 2, 3, 4, 5. And then k equals 2. And then the answer is 4. All right, let's try to see why. Let's see. So I guess you have these, 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 and these that are all 2 apart. Oh, and k is only up to 500. Okay, cool. So let's see. Looks a little harder than the standard 1800. Yeah, my first impression was like, this seems tough. Like, I feel like I remember seeing this problem in the context of you need some fancy technique, and I skipped it because it was too hard. Um, but but maybe not. I guess is VK Cup like a special contest where everyone's really good? So I guess the first thing is it seems like oh, actually you can't even never mind. I was going to say there's a simple NK solution where you just traverse everything within K of every node, but that would actually be n squared. Hmm. All right, well, I guess let's figure out what NK is. This is from 2012. Okay, yeah, I think 1800 in 2012 is like probably really high. All right, let's look at the standings from this contest, and I'll get a sense for. Oh, well, seems like a lot of people did this fairly quickly, though I'm seeing a lot of famous names in this contest. It's kind of funny. All right. This problem was mentioned at the bottom of this post today. So if I click the link, will that spoil me? Oh, I see. Ah, okay. This is a centroid decomposition problem or a set merging problem. All right. Let's see. Distance apart. Yeah, no, I definitely knew it was spoilers when I clicked. No worries. All right, maybe for CSL 99s, you can do O of n. Oh, okay. This is actually different from that problem. I see. All right. I guess I was thinking of just looking at the editorial and then discussing it for to answer CSL 99's kind of explanation request. Maybe I'll just do that. All right. Root the tree. All right, seems legit. So basically what we're going to do here is I'll try drawing over here. So we're going to arbitrarily root this tree. So let's do it like this. And then I think for each vertex, um, what they were saying is you can figure out how many vertices there are in that subtree with a certain distance from them. Wait, hold on, that doesn't really make sense. Let me try rereading this to understand it better. I do see why. I do find this editorial a little bit hard to read, so definitely agreed. CSL 99. The number of ways length K. Oh, I see. Okay. So it's saying you imagine some arbitrary node V like this, and then what you do is you consider two separate types of paths. You consider all the paths that go down from it, and then you also consider paths that go like through it. And either one of those could be of length k. Let's see, does that make sense? Yeah, okay, cool. So the way they start their DP is for every vertex, they say the number of things in their subtree that have this distance to them. So for 4, it would be like there's only one thing and it's distance 0. For 3, there would be there's one thing at distance 0 and one thing of distance 1. And then for 2, for example, there's two things. Well, there's one thing at distance 1 or 0, of course. And then there would be two things of distance 1 and then one thing of distance 2. So to calculate this for any node, we just need to look at all of its children and basically take the union of all its children and then add 1 to all the distances to shift them all over, because you have like if this is the answer for the child, then you have to add this edge. So you have that this becomes 1 1 2 1, and then this one that used to be 0 1 becomes 1 1. And then when you add these, you get this. So you calculate that, and then once you're done calculating that, you can use that to the number of paths that of this blue type that end at the root of the subtree is just going to be the number of things that are length k away from it in its subtree. And then the number of ways to do the other path thing that they mentioned would be, let's say you have k equals 7, then you might have something that's distance 2 away and something that's distance 5 away, as long as they're in separate children. I don't know. CSL 99, did that actually help? If you're still watching. Like I was thinking maybe just the diagrams were enough, but let me know if you want me to explain anything further. And then meanwhile I'll go over this count pairs problem that was mentioned. Oh, okay. Let me know if there's a specific part that I should discuss more. DP state. Yeah, that's this DP state is this I guess this cyan. Is that cyan? I guess blue. This blue thing in parentheses is the same as the DP state that Neil mentioned in the comments. Yep. Yeah. And yeah, to reiterate, for example, if you have this, yes. Oh, I see. The way that you're explaining it, are you doing kind of the whole thing at once as opposed to doing this kind of pre-processing that they mentioned and then computing the answer? Yeah. Um, yeah, so the pre-processing, and the thing that I was outlining here was for each node, first you find the count of, can I make a text box? Oh no. So this is like what the pre-processing is, and then for the answer, you just count the two separate types of paths, ones that go to the root of the subtree and ones that go through the root of the subtree. Oh, and by the way, one other note to actually make sure that we're counting things properly is for each pair of nodes, if you draw the path between them, that path has a unique highest vertex in the tree. So if your path goes like this, it would be like the peak of that shape. And if your path just goes vertically, then it would be the highest node in that shape. So like if you so what we're doing here is for each vertex, we're counting all the paths for which our vertex is the highest node of that path. And that's why we're counting everything exactly once. If that was also, I guess, maybe a slight non-obvious observation from this problem. All right, so let's discuss count pairs. I guess I could code this up. That would be, yeah, maybe I should code this up. I guess I haven't really done much coding on this stream at all, so. Okay. So, all right, so let's I guess compute our I guess first we want to actually root the tree. And then we also want to compute I'll just call this dist. So for each vertex, we want to compute the frequency of things that are confining the distance between two nodes in a tree solved by binary lifting. I think so. Yeah, I think what you could do if you wanted to find the distance between two nodes would be, well, I think the cleanest way to find the distance between two nodes in a tree, if you want to query it, is to find the lowest common ancestor. And then once you find the lowest common ancestor, the distance is the sum of the distances from your first vertex to the LCA and the second vertex to the LCA, because the path between them must pass through the LCA. And sometimes the LCA will be one vertex or the other if one is a direct ancestor of the other. But I think you can also use binary lifting in the sense that you can find the LCA using binary lifting. I'm not 100% sure how to do that. Yeah, if anyone else in the chat has a reference, please please drop it, I guess. But I think finding the two nodes is a pretty standard problem, so you don't necessarily need to reinvent the wheel. So let's see. So what we want to do here is when we get to a node, there it's usually called jump pointers. All right, let's research this. Oh, I guess what you would want to do is you would want to, from one node, go up until they're both at the same depth, and then you would want to go up further until they matched each other, and you can binary search on that to find the LCA. But to answer your question, qualified, every solution that I know of like would first find the LCA. um, and I personally, whenever I have to do an LCA problem, I have like a pre-written LCA class or struct, and it uses sparse tables, so it's a little bit faster than binary lifting, I think, because it's O of 1 instead of log n. Let's see. So anyway, getting back to this problem, so we want to go through all the neighbors. If parent, so if we don't want to visit our parent again, um, no need to do that. So this is a basic DFS, and then we want to set the parent of the next node to the current node. And then we want to do the distance thing. So this line here should be doing the thing that we described where if you have something that's distance like 10 from your child, then it should be distance 11 from you. So that's why we're adding 1 here. And if something is distance k from the child, we actually just don't care about it because then it would be distance k plus 1 from you, which is not relevant for the purposes of this problem. And then the other thing we want to do is we can initialize all the, no, I guess we want to do this. This is to represent the current node. Cool. Let's just try running this to make sure we even did it right. Man, how do I? All right, this is very not correct. Oh, I forgot to actually call my DFS. I always do that. All right, so let's let's refer back to our example. So what we had here is for node number 2, the second one, we had one thing of length of distance 0, two things of distance 1, and one thing of distance 2. So this checks out. Actually put this up in the corner. It's a little more useful than... Cool. So now they're done with that, what we want to do is... Do we have to find the answer mod anything? No, I guess not. So this would be the root node I, and then we would want to go... We'd want to go through all the children. And then again, we want to do if you don't want to look at your parent. So we skip that. And then we have the two cases. Actually, the first case I can put straight here. So this is when you have a path straight down from the subtree root, like the blue paths in this diagram. And then we want to implement what the editorial recommended for the red paths. So what this would be is, let's see. All right, let's just call this, so we're going to want a plus b equals k. And then what we're going to want to do is and then here we want to divide by 2. I think the nicest thing to do is to divide by 2 at the end. All right, clearly something's wrong here. Let's try to think about what it is. Oh, right, okay. Here I'm looking at like, wait a second. All right, so this code actually doesn't make any sense. Okay. So what we actually want to do, let's write this out the very explicit way. Well, okay, so the problem here is that when you want to consider all pairs of children to go down for the 2 branches of one of these red paths, you actually might have to consider n squared children, which is super annoying, in the sense that it'll TLE. So what you want to do is for each child, you don't care which of the other children you consider as long as it's not as long as it's not the same child. So what we can actually do here is so what we could do here is we're iterating over all the possible pairs of distances. And what we want to do is so what this will do is this will tell us all the paths of length k that go through our root vertex. However, it'll double count paths that cross back over themselves because they go to the same child of the root vertex. Um, so that's not what we want. So what we need to do then is we want to subtract out everything that's just within a single root vertex. I probably could have written this more clearly. Wow, this is definitely some spaghetti. All right. So do we actually want to do the thing that I said? Yeah, we do. But let me write this using like a normal for loop. So here what we want is we don't want A or B to be 0 because that would mean that we're doing the stuff that we already counted. So, though actually we could actually just include 0 and then delete this. That's actually nicer. Yeah, because we always know that distance I0 is going to be equal to 1. So that correctly counts the stuff that we want. All paths through the root, but we count some invalid ones. Okay, cool. So then what we want to do is for each child, we want to basically count this quantity, but we need to subtract we need to subtract 2 from k, basically. So okay, great. So this passes the samples. However, there's actually a bug in it. Let me scroll up so people can see all the code. Does anyone spot what that bug is? I'm pretty sure there's a bug at least, which is there should be overflow here. This is kind of a common gotcha, right? So these actually, would there be overflow? N choose 2. Oh, there actually probably wouldn't be overflow here. I don't know why there, but I guess people might use 64-bit integers? Wait, now I'm a little confused. Okay, so I think there may be, I mean, it's always kind of safe to just not think super hard. And if you're worried that there may be overflow with this multiplication, so the problem is even though answer here is 64-bit, these numbers are 32-bit, and it computes their multiplication first and then adds it to answer, which could cause an overflow. All right, so let's just try submitting that. Cool. Um, all right, let's go over count pairs, the next problem that was recommended. Okay. So for this problem, what we're doing is we're given a bunch of numbers, and we have to calculate the number of pairs of indices that satisfy some complicated expression. And at first, this seems kind of tough. Kind of a natural way to break it down would be like, all right, what are all the values of AI plus AJ? But then you want to consider, all right, but then what would the values of this sum of squares be? So there's kind of a trick to it, and I did this a long time ago, so I don't actually remember how I came up with it. I just remember the trick because it's a little bit of a famous problem. So if anyone has a good intuition on how to actually motivate the trick, that would be awesome. But basically the idea is this. So we have two numbers x, whoops. So let's just use x and y instead of AI and AJ for convenience. So we want two numbers xy so that x plus y times x squared plus y squared is congruent to k mod p. And from now on, I'll probably just write equals instead of congruent to k, just for kind of simplicity. So the trick is that we can multiply both sides by x minus y. So we get this on the left. Cool. Bodhi575, thanks for the follow. Definitely looking forward to seeing you in a future stream. So, yeah, so the trick here is this thing on the left now is a difference of squares, which is x squared minus y squared. And now these two things form a difference of squares as well. So you end up with x to the fourth minus y to the fourth is congruent to x minus y times k. And then Oh, CSL99, thanks for the follow. Also, just to double check, do you guys hear a tone when someone follows? Or is it just a little pop-up, I guess, here? Let me know in the chat. Thanks. So there's this rearrangement where you get x to the fourth minus x equals, oh, whoops, sorry, x to the fourth minus x times k. Let's just use the eraser. So I guess the general intuition behind this problem is you want to separate your variables x and y from each other. Because once you can separate them, you can kind of think about each one separately and things get a lot simpler. So in the original expression here, if you imagine expanding this out, you would have x cubed plus x squared y plus some other stuff where they're kind of jumbled together, which is more difficult to work with because then the naive solution to this problem would be to iterate over all pairs, which would be quadratic time. Now that we have this function of x or y, we just want it to be equal on both sides. With a small exception, right? So this isn't actually, there's a little trick, right? So this isn't exactly equivalent to our original expression. The problem is we multiplied both sides by x minus y. So you'll notice that whenever x minus y is 0, or x equals y, all of this working mod p, by the way, that this will always be true. But that may not necessarily have satisfied the original. Oh, all right. Actually, forget about that because the problem statement says it is guaranteed that all elements are different. And not only that, but the elements are between 0 and p minus 1. So if they're different, then they're also different modulo p. And I guess the last little bit of this problem is because we're working mod of prime, things like multiplication and multiplicative inverses and stuff are all like very clean and simple to work with, so you don't really need to worry too much. So I guess let's solve an example using this method. So we'll define f of x equals x to the fourth minus kx. And then let's look at the first example. So, oh, super MZ11, thanks for the follow. So for the first example, we have AI equals 1, 2, 3, 4, 5. Actually, this is the second example. And then we have P equals 7, which is a prime, and K equals 2. So now we can compute f of AI. So for each element, we're just going to compute it to the fourth power, and then we're going to subtract 2 times that element. So the first thing would be 1 to the fourth minus 2 times 1, which is negative 1. So that would be 6. I guess the next one would be, should have picked a smaller example. I guess the next one would be 5. Then 5 again. I guess 81 minus, is that right? Yeah. 1 minus 8, 73. I think this is right. Anyway, if we then put these into buckets, then we have, um, let's say we have f of x, and then we have x. We have 6, can be 1 or 5. 5 could come from 2 or 3, and 3 could come from 4 or 6. And then any two elements from the same bucket can be paired up. So this would be 2 choose 1, or sorry, 2 choose 2, which is 1. And then these would actually be the same. So the answer ends up being 3, which is correct for this sample. And I'm not going to implement this, but I'll just look at this implementation. So we can see here that what you do is you basically outline you just implement what we outlined on paper here, which was you have this transformation x to the fourth minus kx. It's written like this because of, Java. Yeah, so actually, I no longer use Java. I used Java for like a decade or so of competitive programming. Well, not continuously. I stopped doing competitive programming for a lot, but I used Java until a couple months ago when I switched to C++. Um, but yeah, basically what we're doing is we're doing this transformation of x to f of x, and then we're bucketing things by the value of f of x. And then for each one, we're just computing the number of ways to pick two for things from that bucket and adding that to our answer. Um, yeah, let's see if someone implemented in C++. We can see if their code is nicer. It's not. Cool. But I guess that's because they don't have a modnum class, which is essential. Cool. Yeah, does anyone have any other problem recommendations or topics? Definitely shout them out in the chat if so. And I guess I'm actually pretty curious about this. I'm curious kind of the general level of my viewers. What made you change to C++? All right, I'll definitely answer that in 1 minute. Curious about the distribution of ratings of my viewers. If you're comfortable, shout out your rating in the chat from CFer @coder. Example. Yeah, I'm kind of just curious about the average level of my viewership, just to kind of know what problems, what types of problems and concepts I should cover. All right, looks like a couple of people have. Wow, looks like the people in the chat have pretty high ratings. um, cool. So maybe I should, and I guess I could kind of see that from the problems that were requested were harder than the problems that I was doing not by request. I'm 1500 in number theory skill. Oh, actually, thanks for reminding me about number theory. Definitely want to plug this for my viewers. So tomorrow I'm going to be doing a number theory stream. So I put together this mashup along with some help. So thanks Neil if you're still in the chat, and thanks John if you watch this on YouTube, I guess. But I put together these problems. They're ordered by difficulty, and the ratings go from, I think, 800 to around 2300. So there's definitely a good spectrum. it looks like a bunch of people have already have all wow, so one person's done all of them already. That's awesome. But I'm going to be going over all of these and definitely discussing the solutions written out on like the whiteboard and probably implementing some or most of them, as well as trying to cover any topics that you kind of need to know as a prerequisite. So yeah, definitely try out this set before tomorrow. Um, Super MZ, what's your Codeforces username? I'll look out for your submissions. Oh, yeah, no, this is not the number theory stream. The number theory stream is tomorrow. It's almost exactly 24 hours from now. This is just kind of a casual. Oh, you're Go Lions. Are you from TJ? I think I remember you from a problem from a round announcement. There was the round with all the Omkar and blank problems. Um, yeah, cool, cool. I am LLM. Also, did the stream just go out for anyone, or was that, or did that not happen? Did the stream have a short outage for anyone else? Cool. So I guess Go Lions. Yeah, definitely check out these problems, and then we'll be able to discuss them all tomorrow. Yeah, I think the last few are probably pretty tough. I actually haven't even done this one yet, but yeah, should be fun. Cool. People are saying the stream is fine. Oh, and then Sneak Toggled posted a problem. Let's check it out. Nice. All right. Apparently, this problem is easy, so that's good to know. Um, all right. XOR. All right. So here's the problem that was posted. Let me display it. Have I done this round? I wonder. Why am I? Wait, why can I see the tags if I haven't done this problem? Or have I done this problem? Okay, apparently I have done this problem, but it's not showing up. Maybe I did the div2 version of it? Okay, it looks like I did, and for some reason I did it for. Oh, I guess I was doing practicing. Um, cool. Let me see if this works. Oh, cool. So that actually worked. I can just use the chat to. I've been using the dashboard. Vinicius Resende, thanks for following. Um, cool. All right, let's try to go over this problem. I feel like I remember this vaguely. Ah, Sharmady, thanks for following. I bet asking chat to share their ratings biases heavily towards higher ratings. That's true, although I noticed that nobody rated above 2,900 commented their rating. And I think there might be one of those in the chat at least, so maybe not. Sneak Toggle, thanks for following. Cool, so I guess let's look at this problem. Yeah, how did I do this? This is kind of weird. Oh, I wasn't here earlier. Got it. Magic number 12, thanks for following. Also, let me know if anyone has any ideas for if I should set up like a follower goal or something like that. I can't really think of anything though. I'd kind of just, I don't know, do what I normally do. All right, so let's try thinking about this problem a bit. Um, oh, Provoke for it. Thanks for following. All right, I'm trying to refresh myself on this problem because I remember um I remember doing this, but I remember being a little confused about it myself. um okay. So XOR problems scare me. Yeah, I feel like XOR problems are either really cool or really annoying. Kind of depends, but I definitely prefer XOR to either and or because I think they're a little bit by the way, I think there's an XOR problem on the number theory set. Maybe not. I think there's one that features the word XOR at least somewhere early in the set, so it's probably an easy one. All right, so basically, let's make some initial observations. So I'll put them in a text box. So each node has one. Let's just call them outgoing edges. I know it's an undirected graph, but let's just say that if you're going from I to j, where j is the thing that minimizes whatever this quantity is, each node has one outgoing edge. Therefore, in order to form a tree, we need exactly one two-way edge. I think this is right. Yeah, so we'd have n edges, and a tree would be any connected graph with n minus 1 edges. Ugh. So let's try to read my code and understand how this actually makes any sense. Yeah, I've only started using Jamboard today. Normally, I have this. I just use like a legal pad and a pen. Um, but I'm using a Jamboard so that people can see it. Um, Sachin Patel 9135. Thanks for the follow. Let us know in the chat what that number means. Elephant 552 and qualified 9898. Thanks for following. Um, okay, cool. So let's actually read the problem statement again. Okay, so I think I recall this problem a little better now. So basically what we want to do is we want to connect something to the other node where when you XOR them, it minimizes the value of the XOR. So what this would mean is in order to minimize the value, you want to cancel out as many of the most significant bits as possible. So if, for example, let's look at one of the examples from the thing. All right, 0, 1, 5, 2, 6. Is this stream just graph and tree algorithms? No, it's actually anything. So let me know if there's something else you want me to go over. I guess were the last couple problems graph problems? I guess one of them was so far. um, this problem is actually not much of a graph problem. I feel sometimes you have problems that have like some bitwise manipulation and then at its core it's like a graph or tree problem, and I feel like this is one that has graph and tree stuff, but then once you take that away, at its core it's a bitwise related problem. um cool, so I guess let's look at some of the examples here. So if we look at the second example, we have oops, we have 9, which I guess is this. Then we have 8, which is this. Then 7, 6, 5. Oh, Roshan GG, thanks for the follow. And then 3, and then 2. So what we want to do here is you can so if you bucket these by what their most significant bit is, you always want to pair something with something else in the same bucket if it exists. So what that means is if you have a bucket, and when I say if that exists, I mean if the bucket has more than one element. So, oh, 1 second. Cool. So in this case, these point to each other. And then within this bucket, everything points to something else in that bucket, and then these point to each other. But basically, it's clear that the buckets are separate, if every bucket has multiple items. The reason for that being that if you can cancel out the most significant bit, you definitely should, and you definitely don't want to introduce anything higher than that. So you'd want to try to XOR it with something that has the exact same most significant bit. So what this means is once you split these things into buckets, every bucket, and we only want, sorry, um, let's see, what's the best way to say this? So you have exactly n edges. So you can only have one edge that stays. You can only have one edge that doesn't increase the connectivity of the graph. N minus one edges increase the connectivity of the graph until it's fully connected, and then one edge at the end can just do whatever. However, if you have stuff within a bucket that only points to other stuff within that bucket, then I guess you don't even need to say it like that, do you? No, I guess you do. You should only have bucket of size 2. Um, so you don't necessarily only want buckets of size 2. For example, if you have multiple buckets of size 2, that would still be a problem because here, if we kind of draw out this graph, I'll draw the numbers here in a different color. 7, 6, 5, 3, 2. Whoops. So the problem here is you would have 9 connected to 8, and then you would have 3 connected to 2. But then these would never actually connect to each other. So the only way something can go outside its bucket is if its bucket is of size 1. Therefore, you want every bucket to have size 1. And if something goes outside of its bucket, it can only attach to another existing bucket. It can't connect to other buckets. You can kind of think of it like if you have this graph already, which has 2 separate components, and you want to add a new vertex, let's make it green, you can connect it anywhere you want, but you can only connect it to one place. So once you have these 2 separate components, there's kind of no coming back from that from adding other integers. If you imagine kind of building your graph a little bit at a time. So we can only have one bucket that has multiple elements. And so as a result, so that's our first observation. Let me write that down. Observation, you can only have one, at most one bucket with multiple elements. Where again, here our buckets are bucketing things by the, I wish this were smaller. Okay, yeah. You're bucketing things by bucketed by MSB. The most significant bit. So, all right, so that's our first observation. Then we kind of have to consider what happens to stuff that's part of its own bucket. So imagine you have a bunch of stuff and then you have a single number. Let's just use this number as an example. So this has 4 bits. And we're thinking about what to connect this to. If we connect it to anything above it, that would mean that the result of your XOR would actually be greater than this number. And in fact, it would be a lot greater. Like if you had something above it that was like a 1 followed by some digits, and you XORed these, The problem is whatever your result is, it would have this 1 in this place that you couldn't get rid of. So that means you want to connect it whenever possible. You want to connect something to something that's below it in this descending list. Okay, so if every bucket connects to a bucket lower than it, then, and you can only have one bucket that has multiple elements, then what? Okay. So only the smallest element, only the lowest bucket can potentially connect upward. Let me see if I can erase this. Okay. Let me keep typing here. Only the lowest bucket can connect upward, because if there's something, I'll actually just put that as a therefore. Only the lowest bucket can upward. So this means that if you have many buckets, all of them will connect downward, but then you still have one like large bucket somewhere. So let's say you have a bunch of buckets of size 1, and then you have a bucket of size 5 somewhere. Every bucket connects downward, and the 5 doesn't connect to anything. And if you want to connect upward, you're only going to connect exactly one upward, because why have a higher most significant bit than you need to? Like in this analogy, if you have nothing, or in this example, if you had nothing above this, or if you had nothing below this, sorry, and you had multiple candidates above it, you would want to pick the shortest one. So what this means is, so our non-one size bucket has to be bottom or second bottom. Okay, so with these observations, I guess let's just look at our solution. I think we're getting most of the way there. The last thing to note is that if you have a bucket, everything connects to something else within that bucket, but you still need to make sure the bucket itself is connected. And the way that you would do that is you would take off the first bit because it's the same for everything, and then you would recurse on that bucket. So let's look at this code. So here we have this function f, which I guess describes the minimum number. No. Let's see. The problem says the minimum number of elements to remove. Instead, what I did here is I had this thing represent the maximum amount of elements that you can keep. So then the answer is just n minus this. Also, this code is a little bit weird because at the time I took this as an opportunity to learn about C++ iterators. So instead of using indices, I have iterators everywhere. So we start by just looking at the whole array, and then we copy it into this local array A, just for convenience. Then if you have a bucket of size 1, you don't need to do anything else with it. So it's like fine. So you just return 1, you can keep everything. Then you check to see if, sorry, yeah, okay, that's right. Then you check to see if everything's in the same bucket. And if everything is in the same bucket, what you want to do is you want to remove the most significant bit, which I just wrote this convenience function for, so I didn't make off by one errors. You just remove the most significant bit from everything, and then you just go one level deeper in the same bucket and make sure it's valid, and you just return that answer. Then what we want to do is we loop through all of our buckets, and so what this does is this buckets our stuff by most significant bit. This little loop is kind of a common construct, and it lets you process the range I comma j here, where it's each block or bucket by whatever this condition is. In this case, it's equal most significant bits. And then what we do is we consider the possibility, what if this is our only non-size 1 bucket? So if it is, we need to delete all the buckets before it. So this is how many buckets are before it, except for 1. And then the amount of stuff that we can keep, which I guess I called gain, but maybe should have been called keep, is whatever the answer is for just this bucket. And everything after it, wait a second. Oh, and everything after it, we would want to, oh, okay, I see. This is a little bit weird. This count maybe would be more clear if it were in here, but we don't know the answer until we're done with this loop. But basically the idea here is that if you have a bunch of buckets, you want to consider, I'll draw this on the thing. Let's say your bucket sizes are 3, 1, 1, 5, 6, 7. And let's say we decided this is the bucket that we're going to keep, 5. So now, for each of the buckets before it, we can only keep one element before it total, because we can only have at most one bucket before it, and all the other buckets need to be of size 1. So everything here, that's only going to be 1. Wait a second. Yeah, okay, cool. And then everything here, so then everything here, we can keep all the buckets, but they all have to become size 1. So that gives you 2. And then this one, you get whatever f of this bucket is. And that's basically what we're doing. Oh, someone said, hey guys, and someone said, vo hi yo. Wow, I actually need to get more familiar with these Twitch emojis. But yeah, okay. This makes a lot of sense. Okay. That's actually really good to hear because I was kind of figuring this out as I went along. I remember at the time, I think I tried to solve this problem during the contest, though I wasn't actually competing in the contest, and I spent a very long time on it. And then I ended up having a couple different implementations that were varying degrees of messy. Yeah, this one, I have before, regained, lost, and then all these cases. But yeah, I think this is the most clear way to think about it, though it still takes a bit of thinking. By the way, if it's helpful, here are my submissions for distance in tree. Oh yeah, definitely interested in seeing that. So as a refresher, I'll open the distance in tree on the right. Oh, I guess I'll just switch the Jamboard to my diagram. What's funny is they're very similar to each other. Okay, so this is the O of n solution. Ah, okay. This is like a tree DP. All right, I guess this is the core of the code. I would look at O of NK first. All right. Let's do that then. Um, nice. I see Neil is a horse fan, so he has nays all through his code. Whenever he does a tree problem, I feel like I see nay in it. So definitely like a horses in the forest kind of guy. Um, DFS 0, 1. So I guess total. Oh, total is like a global variable. Okay, cool. So result. It's just result is just this vector that you described. My neighbor is a horse. Is that actually true? Because I actually remember where I grew up in Maryland, my neighborhood had a bunch of horse farms nearby, though it wasn't like a rural area at all. I'm not sure why there were one or two horse farms near there, but there were. um, so let's see. Root.counts.insert. Right, okay. But this is this distance d from the root? I guess I guess it is. So this is okay, I see. So when you mentioned the thing about pre-processing, you are basically doing the same thing as the pre-processing solution. You're just computing the other terms as you go as well. Okay. So when you have a child to attach to the root, oh, this is kind of cool. So you actually don't need to divide by 2 because you attach the children one at a time. So this automatically enforces an ordering on the 2 children that you pick. Let me know if that's right, but I think that's right looking at this code. Um, and then cool, yeah, okay. And then root.counts here. At some point, this is 0, and that's when you do the purely vertical paths, the blue ones over here. Okay, that makes sense. Charlie Dime, thanks for following. All right, now let's look at this, I guess, O of n solution. So, wait, wait, what the heck? So the result struct here is a deck. Oh. Okay, this is pretty cool. So I guess is the idea that when you're done with a child, so the idea here is that when you're done with a child, you never actually need its array again. And that's actually why it's kind of important that you're not doing it this pre-processing way. So you never need its array again, so you can use its array as the parent's array. I guess, is this like a small to large merging thing? Yeah, okay, I guess so. Okay, this is pretty neat. So I guess, let me see. Is this actually what I understand? Why is this n log, or why is this n instead of n log n? Oh, I remember this post. Oh, okay. I like this. I like this Eden imagery. Nobody kneel. Nice. I guess that meme doesn't work quite as well when you can't do new lines. Um, it's a little annoying that Twitch filters it out, but I definitely understand why. Okay, this is pretty cool. And I guess, hmm. Okay, and I guess like these arrays could be up to k in length, but you only ever add something at the beginning of an array, so it ends up being the total length. The total number of times you add stuff to the array is O of n. Okay, that's pretty nice. All right, let me close these. Let me make sure I catch up with chat. Cool. All right, definitely. Let's see. Does anyone else have anything they'd like me to go over briefly? I'm thinking of probably ending the stream soon. But definitely feel free to comment on my Codeforces post or message me or whatever if you have any recommendations for future streams. Always happy to hear feedback. Um, and let me just plug my tomorrow's stream because I think that's an important thing in this channel. Okay, cool. Yeah, so as a reminder, tomorrow in, I guess, 23 hours, I'll be doing another stream where I'm going to go over number theory. And there's this problem set of 12 problems, which some people have already started on, which is awesome to see. And yeah, hopefully during tomorrow's stream, we'll be able to go over all the problems. But there are a bunch, so I guess we'll see what the pace is. And yeah, I'm definitely looking forward to it. Um, and as a quick reminder, please follow. If you follow, I think it might make the stream more visible. I'm not exactly sure how that works on Twitch, but you'll also get notified when I'm streaming if you choose to turn that on. You can also turn off notifications, and I think it'll make it show up on your homepage if I happen to be streaming when you're on Twitch. Um, yeah, and I upload all my past broadcasts to YouTube, which is probably the best place to watch them. The reason for this being, I believe the Twitch broadcast disappears after a little while anyway. And also on YouTube, I typically annotate my broadcasts with timestamps so you can navigate it more easily. Cool. Well, if that's all, then yeah, I guess I'll end the stream for today. Awesome. I'll make sure to catch tomorrow's stream. Yeah, definitely do that, and um, definitely try your hand at the mashup. Yeah, glad I could go over the problem as well. This is definitely a fun one to go over because I think you suggested XOR tree, right? um, Let me see. Yeah, XOR tree was definitely fun to go over because it it helped me clarify my understanding of it. Because I remember at the time when I was doing it, I was kind of like, it was a while ago, and I remember being a bit confused. Um, Sharky Boy says, "Thank you. Can't wait for tomorrow's stream." Yeah, I'm super excited. I kind of wish it were now, but I'm also glad that people have more time to look at the problems on their own because I think that'll be really valuable. I definitely enjoy doing these streams, but I also think that it's most valuable to viewers if they get a chance to read and think about the problems on their own instead of just seeing the solutions from me. Um, but yeah, all right, cool. I'm gonna end the stream. Thanks everyone for joining, and I'll see you guys tomorrow.